we have partial derivative with respect to y is what we're looking for. But then you can see in number 4, it's going to ask us for all second order partial derivatives. So it's kind of like, well, you know, why not just do both anyway? So, and again, the notation, I leave that up to you, but most people, whether they realize it or not, are going to end up preferring the f's of y as opposed to the, you know, writing out the partial with respect to y. You know, that's a lot to write. You know, so a simpler way is just the f with a subscript of y. Right? So here we're looking at when we're doing it with respect to y, and it's very important because people lose sight of this. You kind of default back to your Calc 1 knowledge. What we're looking at is a function that's in terms of x and y. However, I want to only focus on the variable being y. All right. So it actually kind of makes things a lot easier. Not in all cases. Sometimes it can get pretty kind of confusing, but in this case, it's really not that bad because I'm going to treat the x component as constant. So the only part that I'm really thinking of as variable is the sine function, and then also the e to the y power. All right. So I'm looking at cosine of x being basically a constant multiple of the sine of y. With derivatives, when you take the derivative involving a constant multiple, you hang on to that constant multiple, cosine of x, and then multiply it by the derivative of the parent function within the expression. Derivative of sine of y is cosine of y. Right. Then the e component, just I'll jot it down right above it because I know people forget this. The derivative with respect to x, for example, I'm just going to go old school here, of e to the u of x. I'm stripping it down, no coefficients there, would be e to the u of x times u prime. That's the general chain rule relationship. All right. And so what I'm doing here is I'm looking at this as e to the constant multiplier of y. All right. So it's going to be minus. So basically keep it as is, e to the xy, but then multiply by the derivative of just the y with x being the constant multiplier of y. So the way we handle it again is we hold on to the constant multiplier and multiply that by the derivative of the parent function. In this case, the derivative of y with respect to y would just be a 1. Right? And then you can clean it up. There's not much cleaning to do here, but every little bit of cleaning will be rewarded later on with simpler computations in your second derivative, second order partials with respect to x or y. All right. So let me kind of zoom out a little bit so you can have a fighting chance of seeing that. And while I'm doing that, I'm going to take a sip of water. Now, again, like I said, we're going to have a need to come up with all second order partials with respect to, you know, so x, x, y, y, x, y, y. So, you know, why not take care of that in this step also, even though it wasn't asked for. You know what? I'll take it as a typo. You know, number 3, I'll make it a part B. You know, ask for a partial with respect to x. So get those typos in. And what I've kind of noticed, and this isn't, oh, there we go, cool. You know, I noticed that the same group of people tend to submit typos, and that's great. You know, I had originally decided, you know, kind of had it in mind that there would be a max number of points for typos. there still is a max, because otherwise, you know, with the amount of typos that I make, a person can get an A in the class without actually knowing any math, just by picking up all the typos. You know, some of us will be like, oh, sign me up. But, you know, if I, you know, I kind of see that the same group of people is or are submitting the typos, and there are some people that just, you know, I guess, I don't know what they're waiting for, but it seems as though they don't really have an interest in doing that. That's fine. You know, it's bonus, so it's not a requirement. But I just figured I'd just keep giving those points to the people who want to do it, you know, within reason. You know, because once a typo is submitted, I'm not, you know, if somebody's waiting for the end of the I almost said quarter, end of the semester to submit like 20 typos, odds are I already have those. So you're not going to get any credit for those. So you want to do it as we go. All right. So even if it means you kind of stop what you're doing and submit, it's definitely worth your time. Right? And it also means, hey, you know, paying attention is kind of a good thing. You know, you're rewarded because I'm going to announce the typos and you're going to get a bonus point for it. Right? So now we're going to switch perspectives here. And now we're going to differentiate with respect to X. All right. So we're treating the Y components as constant. So the sign of Y now is thought of as the constant multiplier of the cosine of X. So I'm going to hang on to the sign of Y. I'm going to keep going with parentheses. And I just realized I missed one over here. Get that in there. All right, so sine of Y, derivative of cosine is negative sine. So times the negative sine of X. So then when we take the derivative of e to the xy, it becomes e to the xy, but now y is the constant multiplier of x, right? So hang on to the y, so times y, then take the derivative of just x with respect to x, and that'll give you the 1. So a little bit of housekeeping, negative sine x, sine y, minus y e to the xy. Now, if I could give you any advice when it comes to this second order partial stuff, that piece of advice would be try, and it unfortunately is not going to apply here, but if you could find a trig identity that simplifies the expression that you're working with, you'll thank yourself, right? So just something to keep in mind, because, you know, you see cosine x, cosine y, part of that actually is, or that, I'm sorry, is part of a sum or difference identity for sine and cosine, right? So, you know, it's little things like that that could save you some time, you know, and there's a reason why I'm giving this as a hint, because that is a time saver that you could expect to see on the next unit test. Okay, well, I'm going to throw a problem in there. It's going to ask you to do all the second order partials. And just that little bit of extra thought associated with the first order partials will save you an insane amount of time. And I'm not really exaggerating that. It's the difference between like a few lines of work and like a page of work. All right. So look for those relationships. And I'll give you some resources as we go to remind you what those relationships are. So compute all 4 second order partial derivatives. So we're going to take these guys. I'm grabbing this one and this one. And so we're doing the f of x, f sub x, x, f sub x, y, f sub y, x, f sub y, y. Okay. and we'll see there's a nice little shortcut through the maze. So let's go with the generally the easier of the two possibilities would be just going after it the same way a second time. Oftentimes that's the easier way. There are exceptions, of course. So an organizational strategy, I like the highlighters. I got plenty of them. So I use my highlighters and I just highlight the thing or the expression that I know is the one that's relevant to the differentiation. All right. Everything else is going to be constant multipliers. So I'm going to hang on to my cosine of x. Derivative of cosine is negative sine, so negative sine of y. That's with respect to y. Right. Now x e to the xy looks an awful lot like implicit differentiation and all that good stuff, but it's not. And it also looks like it might be a product rule situation, but it's not, because x is thought of as a constant here. So x e to the xy, the derivative of the e to the xy component, right? We already got the e to the xy, but the derivative of xy, x is the constant multiplier, y goes to 1, so that's all you get. That's all she wrote. Pretty not bad, as long as you're thinking about it the right way. So I'm going to clean it up. In this case, I really don't need to, unless we're considering the follow-up questions. But it's not a bad idea, you know, especially because it could be one of those multiple choice questions that you've seen, where it's like you do the work and the answer could take a particular form, and if it's not the same form as the answer that you got, then you got to clean it up a little bit. Although I don't try to go too crazy with making those types of questions, but sometimes it happens. All right. So what I would want to do now is get my, well, I could go one of two ways. I could get f sub x x, or I can get the mixed, right? Either way, I'm going to have to get the mixed. But what I do want to do is consider the nature of the functions, all right? And I'm using functions plural because this is a multivariable function, but each component of this function is in and of itself a function. And each component in and of itself has its own domain. And so you wouldn't have to write this out, but I would want you to consider it. You'd look at the different functions as being cosine x, sine of y, and e to the xy. All right. In each case, the domain, now the domain is different conceptually in each case, because the domain is related to x in the first function, y to the second function, and both x and y in the third function. But I'm just going to write very simply here all real numbers, because I'm not going to do too much more than what the question's asking, but I do want to have it in mind what the domain is here. And what that tells me is that this function is continuous on the domain of all real numbers. And so why is that important? You know, you read ahead, but we've already talked about this. If you know that the function is continuous, everywhere continuous, then we could say that the mixed partials are equal to one another. So f sub yx and f sub xy are going to be the same. That allows me to save some time. I don't have to do the computation a second time. All right. So it really is a matter of, okay, where do I want to do it? I like to get the easy stuff out of the way. So I'll do the f sub xx. And then we'll do just one of the mixed. You know, some people like to do it the second time anyway, because sometimes they forget. That's a possibility. And the other thing is sometimes they just want to verify that the work they did was correct. Nothing wrong with that either. Right. But again, I like to go the highlighter route. The variable in question here is x. So I'm hanging on to X. I'll really just highlight the X there. No, be inconsistent. So I have a negative constant multiplier. Sine of y is a constant multiplier, constant multiple. Derivative of sine of x is cosine of x with respect to x. Now, in this case, again, you just got to consider it, but it's the easier of the situations. Y is a constant multiple, so we're hanging on to that negative y. Then we're multiplying by e to the xy. Derivative is with respect to y, so that gives us the x. So in this case, not too bad, but you can see how if we switch and make it the mixed second order partial, f sub x, xy, that y becomes variable, and then you get you have a product rule situation on your hands. So it's a nice little trade-off decided by the math gods, I think, where it's like, yeah, you're not going to have to compute it twice, but you're going to have to do more work to compute it once. I think that's probably not unreasonable. Question?
Isn't that respect to x instead of y?
No, that's what I'm saying. We're going to be doing with respect to y in a second. I'm saying that we consider that it's with respect to x now, but in a second, when it is with respect to y, we're going to have to think about it differently.
Okay, because you just did the derivative of, wasn't it supposed to be times y?
Well, the derivative of y is 1. Oh, I'm sorry. Yeah, oh, thank you. I see what you're saying. Yeah, I just wrote the wrong thing.
Yeah.
X goes to 1, and then the y just comes along to the right. Thank you, thank you.
No worries.
I sometimes, in the process of talking about what we're about to do, sometimes start doing the thing that we're about to do without finishing the thing that we're working on. What can you do? So anyway, f sub xy, since I'm already here, I might as well do it here. I'm changing up my highlighting. And you know what? Let me do it this way. Instead of changing up my highlighting, okay, well, what is that? Why? That was rude. I just want to move the highlighter. I'm going to just snag this and rewrite it. Oh, and by the way, like, it's the little things that make me happy in life. I don't know why, but kudos to everybody who bought into the digital inking. Because I'll say that the presentation of a lot of the work that I saw when I was grading the tests was really, really nice. And like as you probably discovered, there's a learning curve, especially if you're watching me fumble around with all this. But yeah, there is a nice little trade-off, a little payoff, I mean, and that is, like if you're doing it with pencil paper, you might not consider at all saying, well, let me rewrite f sub x just so I can refer to it with different highlighters. But if you're using the digital inking, it's so easy, like why not? So, and I don't want I don't want to speak for the people who are doing it, because I don't want to say that it's like so easy that anybody can do it. Maybe they're having different, maybe it's a struggle, but they're willing to do it just for the look of it. But I find that more and more, instead of looking for a piece of paper, and this is not just for math, instead of looking for a piece of paper, I'm looking for my iPad. So, but another thing is, and I don't want to spend people's money for them. That with an iPad specifically, there is a big difference, as you saw the night where I forgot my Apple Pencil at school. There is a significant difference when you're using an ordinary stylus and when you're using an Apple Pencil, and I think they probably planned it that way. But yeah, if it's something you've been considering, I'll tell you on my end, when the folks who do do their submissions on tests, they're submitting high quality work. It's very visually appealing, and I got to imagine that things like the copy pasting makes life a lot easier. So I figured I would talk about that for a second, just to shout those people out, because I was very, very pleased when I saw that. Okay. So anyway, the derivative of sine of y would be cosine of y. So I'm bringing down this guy. So negative sine of x stays as is. Sine of y becomes cosine of y. But then it's in the next part where we earn our keep. And that's because this is a product of two functions. Before it wasn't. It was a product of a constant, air quotes on the constant, and a function, because we were treating the y as a function, as a constant previously. But now y is the differentiable part of the function. So now we have two factors in the product, each containing a y. We have to use the product rule. So unless there was some way to simplify it down, not always going to be the case. In this case, there isn't, but sometimes there is. So be on the lookout for that. So first times the derivative of the second. So with respect to y is going to be e to the xy times x plus the second e to the xy times the derivative of the first. Derivative of y with respect to y is going to be 1. So it's really just e to the xy. And I'll put in the plus 1 times 1 there, just so you have it as a reference. But I'm also going to shrink it up a little bit so it fits a little nicer. All right, so that would be my second order mixed partial. All right. And so we can also assume now f sub x, y is going to be the same thing. All right, and again, that's because of the continuity component, because I would imagine, there's somebody who has that question. Well, how do we know that? Because it's continuous function on the domain of all real numbers. All right. Question.
I'm sorry. So that's the derivative of the second, right? Which is e to the x y.
E to the xy times the derivative of the exponent with respect to y.
And the second part is the derivative of the first times the second.
Derivative of the second time, derivative of the first times the second. Yeah, exactly.
And you don't take the derivative of the inner part, which is x times y again?
No, because we're just rewriting the e to the xy now.
Okay.
Because it's not the part, we've already taken the derivative of it.
Thanks.
No problem. Yeah, that the product rule, chain rule, all that good stuff, when it comes to partials, it's very easy to get your wires crossed. Right? So color goes a long way, and just honestly, a quiet environment where you can concentrate, because it's very, very easy to lose your train of thought when it comes to some of this. Number 5, we're going the distance here. Compute the third order partial with respect to x. All right, so since I got to do that, I might as well clean this up a little bit. My second order mixed partial. Again, not much to clean up, but enough to make it worth our while. Enough to consider making the adjustment, because it could be worth our while. So like I said, I don't want to oversell anything. It may not simplify things at all for us, but it's worth looking at. All right. And then, so I'm going to rewrite. It says xy e to the xy plus e to the xy. And I'm also going to factor out an e to the xy just so I can see what it's going to look like. Because if it looks simpler, it looks like something that's easier to take the derivative of, so easily differentiated, that might be worth it. So I'm going to pull that out, and that would be xy plus 1. You know, it still looks like we would have a product rule going on here, but we're going to have a product rule going either way. You know, depending on what we're taking the derivative with respect to. So when I look at xy e to the xy, that was going to be a product rule really no matter how you sliced it, because both parts had both variables, both factors, I should say. In this simplified form, quote unquote simplified form, yeah, there's going to be a product rule, but I think it's going to be maybe a little bit nicer. I don't know, you'll be the judge. All right, so we're finding the third order partial with respect to x. So I'm going to take this because we know this is the same as xy. So f sub xy, f sub xy, f sub yx, they're going to be the same. So, and you can see the equality of second order mixed partials, they're going to be the same, but there's actually more to it than that, which I'll get to in a little bit. I'm going to find xyx. Again, just go back and be careful. My relevant variable is x, and it happens a few times. All right, I'm going to accentuate the two factors here making up the product. So this is product rule. When we differentiate. So the first part, and it's kind of weird because the part that I think looks probably like it would be a little bit more complicated is actually not that bad. So hanging on to the negative cosine of y, I want to go purple on that for those who score at home. And then taking the derivative of sine of x, which is cosine of x, minus, I'm going to put a big old bracket here just so I don't screw up the negative sign part of it, negative SIGN sign. So e to the xy, that's the first function. Then I want the derivative of the second, so times the derivative of the second, which would be with respect to x, just a y, right? Derivative of x is 1. So the 1's going to go to 0, so that would just be a y, right? So that's the derivative of the second. Maybe a little note there for organizational purposes. Plus my second function times the derivative of the first, which is going to be e to the xy multiplied by the derivative of xy with respect to x. So y is what we hold on to, x goes to 1. Okay, so this is the derivative of the first, this whole shebang here. Let me actually squiggly bracket this bad boy here. All right. And since we got to take the derivative yet again, it definitely is in our best interest to simplify. This is kind of like, this is a bit of a payoff for years of promises that I make my students. This is actually the first semester where I don't have, I'll feel terrible if I'm wrong about this. I'm going to say it anyway. I believe this is the first semester where I don't have a student that I also had for Calc 1 and Calc 2. And those students always understand what I'm talking about. Because in Calc 1 and Calc 2, I say, take the derivative, don't even bother simplifying. I'll get you at some point. And the payoff is in this moment where it's like, I never have to intentionally ask people to simplify, because sometimes it's like, well, do you want to take the derivative of something that looks like this? Or do you want to clean it up first and then take the derivative? I mean, I think it makes more sense, you know? So it's a payoff that maybe is landing because maybe your previous teachers told you the same thing. If they had any sense, they would have. But I know some people just, you know, they say simplify. Why? Because I told you to. So I mean, not accounting for those folks. Anybody who had any kind of like math sense would have said, "Don't worry, it's going to happen at some point. Let's not worry about that right now." All right. So I have a common factor here because it's really kind of hard to keep it all straight. I got two, really, these are two whole terms. And within each term, I have a common y and an e to the xy. So I'm going to pull that out, y, e to the xy. And when I remove those, I get something kind of nice happening, because this is going to collapse down. I'll have a factor of 1 plus the only thing that's left on in the yellow highlight is xy plus 1. Which I can further clean up. No, not a whole heck of a lot, but enough. So now what we're looking at is an expression that really is no more difficult than what we started with in this problem. And if you're at the point where you're ready to kind of start talking about what this stuff is used for, don't worry, we're getting there. Because, you know, at this point so far, it's really just like, oh, math is fun, let's do more math. But there is a meaning behind all of these partial derivatives, and there's especially a meaning behind the second, third order, and nth order partials, mixed partials, and all that stuff. It's fascinating stuff, but we're getting closer and closer. Not quite there yet. All right, so now we're gonna, last but not least, and so before I go too far ahead, if the function is continuous, all mixed partials are equivalent to one another. All right. So we got x, y, x. That's equivalent to x, x, y, y, x, 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 y. I might have said that one already, but any permutation of two x's and a y. All right. So that's something important to keep in mind. So the next one up would be x, y, x, y. That, I mean, if I wanted to do x, x, y, y, which actually might not have been as bad, you know, or y, y, x, y, x, x, you know, it's a nice little blueprint. It's a strategy where you say, all right, well, it's easier to find the first order partial with respect to x than it is to find the first order partial with respect to y. So let me go down that rabbit hole. You know, that's very, very important. And it also leads to, you know, strategy. And, you know, I don't want to oversell it, but you start kind of thinking about this as more like a game of chess, where you're trying to think like a few steps ahead. There's not too much wrong with that statement, because you'll find that it kind of plays out that way. Right. So now we're going with respect to y. So I got all this stuff going on here. Now It's up to you, but you see how this y is on the outside. So this is another thing of like, let's play this out logically in our minds. So I have a y here, a y here, and a y here. So using just logical reasoning abilities, I'm taking the derivative with respect to y, not respect to x, right? So that means that y is the relevant function, right? Which means each one of these functions containing y has to be a part of the differentiation process. So I'm looking at three functions, or I'm sorry, three factors containing the relevant function. So like that game of chess I was talking about, maybe there's room for us to say, let's see if we can manipulate this a little bit so that we could have a more user-friendly experience. So what I'm going to do is I'm just going to duplicate this. I don't want to screenshot. I don't even know why I did that circle thing just now. Anyway, I'm going to snag this y. That's this one right here. I'm going to move this over. I'm going to move that over. Duplicate this. Copy. Oh, actually, I wouldn't even need to duplicate it. I'm just going to pop it in right there and then make this y squared. Basically, I'm going to undistribute it. Unfactor it out, which is distributed through. And so it's one of those things, like the best laid plans, because you look at it and say, well, couldn't I have not factored it out to begin with? And be like, oh, you can see the future. How nice for you. How do you do that? Because I'd like to do that. You don't notice it sometimes until you start the process, right? So that's where we're at this point. And so you look at it and say, well, how did this improve our situation? Well, we have two factors now, each containing a y. But then when we get into the one that's in parentheses, there's no need for product rule in there because anything that's not a y is going to be thought of as just a constant multiplier of that y, right? So it's going to make our lives a lot easier. Just that one little subtle maneuver. And I just realized I didn't have, it's not a big deal, but I didn't have parentheses around these. It really is not a big deal at all. It's not even a deal, let alone a big one. But I'm trying to be consistent. So hanging on to cosine of y, hanging on to negative cosine of x. Those are my constant multipliers. The derivative of cosine y is negative sine y. I like the big old bracket approach to things. So my first function, e to the xy, times the derivative of my second function. And this is, again, with respect to y. So we have a 2, and we have a 2xy, plus my second function, 2y plus xy squared, times the derivative of the first function with respect to y again. So e to the xy. And remember, I hung on to that negative sign. And people sometimes say, well, wait, what about that negative? That negative's on the outside of the whole thing, right? I kept that apart. Times the derivative of the exponent with respect to y. So hang on to the x, take the derivative of the y separately. All right, since this is the final move in the process, I have no need to simplify because I'm not doing anything with this. All right, simplifying is always to meet a need outside of an algebra class. In an algebra class, you simplify to learn the skill of simplifying. Here, we simplify to meet a need. All right. Just like we convert to radian form to meet a need, convert to degree form to meet a need. You know, use a trig identity, same idea. You don't do it just to do it. We played to win the game. So that was fun. There's a lot of stuff going on there. You know, some of them are easier than others, obviously. And I'll even say that when you're looking at the polynomial-based one, you might have thought, "Whoa, this is pretty rough." You know, there's a fair amount of writing involved in those. Look at all that writing here. It looked like a lot at the time. It looked like a lot, and then it's like, whoa, okay, I see where this can end up. Yeah. So looking for the shortcuts through the maze is always going to be a good strategy. So keep your eyes open.